So this example is going to be a video on calculating a limiting reactant problem where we're given the amount of two of the reactants. So here's the two reactants, silicon dioxide and carbon. And here, first of all, you need to know what the relationships are between all of the substances. So the balanced chemical reaction, of course, is essential here. And so what happens is you get silicon carbide as one of the products. You would not be expected to know that, of course. And then two COs, which is carbon monoxide gas, and that requires two of these. All right, so the stoichiometry is 1, 3, 1 and 2. All right, I forgot about that carbon right there. All right, so again, the key is that we're given the amount of the two reactants. So the next thing we have to do is convert the gram quantities to moles, then convert moles of each one of these to the moles of product, and then the smallest amount is the one that's going to be the amount we can make. All right, so note that it's not necessarily the one that we have the least weight of. Okay, so this could be the limiting reactant even though it has a higher mass. Okay, so we're going to take each one of these, 70 grams of SiO2, and use the molar mass to get moles of SiO2. And I'm going to look up that molar mass, and that is 60.08. All right. Now we use the mole to mole ratio. 1 mole is 2 moles of CO2. Moles of CO, sorry. And then 1 mole of CO is 28.01 grams. Okay, so this is your standard grams of one substance to moles of that substance, moles of one substance to another, and then moles of the other substance to the grams of that substance. And so with 70 grams of silicon dioxide, we can make 65.27 grams of carbon monoxide. Okay, so now how much can we make from carbon? Well, we start with 50 grams of carbon, and you should get quite good at this sort of conversion if you do it enough times. Convert grams of carbon to moles of carbon using the molar mass. The atomic mass of carbon, 3 moles of C to 2 moles of CO. All right, and then the last conversion factor, of course, is the same for both steps. Okay, moles of CO cancel, we get grams of CO in our answer. And that is 77.74 grams of carbon monoxide. Okay, so one of the things you do not want to do is add these two numbers. So basically, with 70 grams of silicon dioxide, we can make this much CO, and when we get that much CO, we have run out. With 50 grams of carbon, we can actually make more than 65, but when we reach 65, we run out of SiO2. So this is the limiting reactant, SiO2. And this is the excess reactant, the carbon. This is the amount of product you can make. This is the theoretical yield. It's when you calculate how much you can make. It's called a theoretical yield. So the next video is going to talk about a concept called percent yield. Let's say we run this reaction. If we start with 70 grams of silicon dioxide, we expect 65.27 grams. However, this is just the result of a bunch of numbers and calculations. In real life, we won't get 65, we'll get something less.